Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aufa Azfar bin Muhammad Hairul, student ID 2020 457892.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. My name is Muhammad Haziq Danish bin Zulfakar Bledram, student ID of 20208773772.
Assalamualaikum. My name is Nur Hafizatul Najwa binti Ahmad Zuhaimi and my student ID is 2020 475
So we are from group 20. So the topic we choose for this presentation is related rates. So what is related rates? Related rates are calculus problems that involve finding a rate at which a quantity changes by relating to other known values whose rates of change are known. For instance, if we pump air into a donut filter, both the radius and the balloon volume increase, and their growth rates are related. Both can be solved, but it is much easier to solve the volume rate of change. The related rates of change are generally expressed in terms of time. Next, how to do related rates? There are 7 basic steps how to do related rates. First thing first is read and understand the problem carefully. Next, draw a diagram or sketch if possible. Third, introduce notations or symbols. Fourth, express the given information and the necessary rate in terms of derivative. Fifth, write an equation that relates the several quantities of the problem. 6. Use the chain rule in calculus to differentiate both sides of the equation concerning time. Last one is substitute all known values into the resulting equation and solve for the required rate. The next one is what is differentiation? Differentiation in mathematics, process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation, using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate function.
So problem statement. Question number 1. Dan is 5.25 feet tall and walks away from a 24-foot tall lamppost at 4 feet per second. What is the rate of change of the length of Dan's shadow when he is 14 feet from the lamppost? Question number 2. A machine inflates spherical balloon so that the radius of the balloon increase by 5/r/mm per second. What is the rate of increase in volume of a balloon filled by the machine when the radius is 18 mm?
So for the objective of the questions, for question 1, according to the question, we need to find the rate of change of Dan's shadow when he is 14 feet away from the lamppost. And as for question 2, based on the question, we should identify the rate of increase in the volume of a balloon when the radius is 80 mm.
So question number 1. From the diagram here, it is better to draw a diagram to make it easier and level it. So from the big triangle, we can separate it to 2 small triangles. And from this triangle, you can get the information. So first triangle, tan theta equal to 5.25/s, and the second triangle, tan theta equals to 24/x plus s. Then write the equation 24/x plus s equals to 5.25/s. Then cross multiply it. So we get 24s equals to 5.25x plus 5.25s. Then find the derivative. As we can see here, the power of s and x is 1, so 18.75 times 1 and 5.25 times 1. Then from the both side, divide it with 18.75. Then we get ds dt equals to 5.25 over 18.75 dx dt. So the dx, as we can know, the dx dt is 4 feet per second, then 5.25 over 18.75 times 4, and then we get the answer. So 20 ds dt is 28 over 25 feet per second. So the rate of change of the length of Dan's shadow when he is 14 feet from the lamppost is 28 over 25 feet per second.
Alright, so for question 2, let's read along the line. A machine inflates spherical balloon so that the radius r of the balloon increases by 5 over r mm per second. Now that statement means that our dr over dt equals to 5 over r mm per second, because the statement says that the radius of the balloon increases by 5 over r mm per second, which is time. So dr over dt equals to 5 over r mm per second. And now it's asking us what is the rate of increase in volume over balloon filled by the machine when the radius is 80 mm. Now this other statement means that it's asking us to find the dv over dt, because it's asking us to find the rate of increase of the volume of the balloon filled by the machine when the radius is 80 mm. However, to find dv over dt when r equals to 80 mm, we have to find dv over dt first. Now to find dv over dt, we have to do multiplication. So we have to multiply dv over dr, because we are finding dr and we already have the value, and multiplied against dr over dt. So basically it's just dv over dr multiply against dr over dt to get dv over dt. Now the volume of a sphere is 4 over 3 pi r cubed. Then we have to differentiate the volume of sphere to get dv over dr, which equals to 4 pi r square. Now we already have our value of dv over dr and also dr over dt. So we can find our dv over dt, which is 4 pi r square times 5 over r. We can cancel out the r, and now the r only remains 1, which equals to 20 pi r. So now we can find dv over dt when r equals to 80 mm, which is 20 pi times 80, which equals to 1600 pi, which then equals to 5026.55 mm per second.
So for the conclusion, in the conclusion, we succeeded to find our objective of the two questions, which is we need to find the rate of change of Dan's shadow when he is 14 feet away from the lamppost, and rate of increase in a volume of a balloon when the radius is 80 mm by using related rates concept.
For the reference, there are two links here that I will put on the description below. That's all from us. Thank you and Assalamualaikum.